In the last video, we saw how to modify polyatomic ions using the H method, where you add an H in front of a polyatomic ion and it reduces or it increases the charge by 1 every time you add one H. So if we add an H to PO4 minus 3, it would become HPO4 minus 2, and we call that hydrogen phosphate. So you just add the word hydrogen in the front, or you can also call it biphosphate. We could do the same thing for carbonate. We could add an H to it and it would become HCO3, and rather than 2 minus, it's going to become minus because it goes up by 1, and we would call that hydrogen carbonate. You could also refer to it as bicarbonate. If you added 2 H's, let's just say, so we added 2 H's to the phosphate, that would be H2PO4, and the charge would go up by 2, so it would become minus 1 instead of minus 2. And so let's just fix those subscripts there. And again, you wouldn't usually have to write the 1 because it's implied, so you could just say minus. And we'd call this dihydrogen phosphate because you added 2 H's, the di meaning 2. So in the last video, I finished off with this problem here where you had CuH2PO5 with a 2 on the outside. And so it's a weird looking polyatomic ion, but you could probably figure out what it is based on your knowledge of what phosphate is. So you know that phosphate is PO4 3 minus. Now in compound, you don't have PO4, you have PO5. So you can use our tricks for polyatomic ion modification. You have 1 oxygen more than the phosphate. You have 1 oxygen more than the phosphate, you have the per version. You have per phosphate. And you don't modify the charge. Now, in addition to that, there's another modification. You have 2 H's in the front. So you took this PO5, this per phosphate, and added 2 H's to it. So when you did that, it became H2PO5. And what's going to be different here is the charge. Per phosphate had a charge of -3. But when you add an H, you go up by 1 every time. So we added 2 H's, so rather than be -3, we'll be at -1, or just negative. So H2PO5 -1 or negative. So now that we know that, we can go in and try to name this compound here. We added an H to the front, or 2 H's to the front of perphosphate. So this polyatomic ion has now become dihydrogen perphosphate. We had perphosphate, we added 2 hydrogens, and now we have dihydrogen perphosphate. So now we know the formula and the name for the polyatomic ion that's in this compound over here. So this was a multi-step deriving problem where we used our knowledge of the eighths, the ites, and the per eighths deriving techniques to get to perphosphate, and then we used our knowledge of the addition of the H to get to dihydrogen perphosphate. So in this case here, we're going to have copper, something, we have to figure out its charge, because we know copper is a multivalent element, dihydrogen perphosphate. So to figure out the charge, you have to do the reverse crisscross. Take the subscript from the bottom over here, bring it up to the copper, take the subscript where the copper is, and bring it up to the other side of the H2PO5, and so you get Cu plus 2 H2PO5 minus And the reason that I really want to come up with this formula here is just to make sure that this charge was right over here when we did the reverse crisscross, and it is correct. So we know that this compound was not reduced. It didn't have to be reduced, so this is the correct charge of the dihydrogen perphosphate. But we also know, more importantly, that this is the correct charge of the copper. So we have copper 2 dihydrogen perphosphate. And if you are using the Latin system of naming, let's make some room here, you would have cupric, because it's the higher valence of copper. So cupric dihydrogen perphosphate. So this video was just to show you more depth on the naming of a compound, where you have to do maybe multiple derivations of your polyatomic ions. So make sure that you practice this. If you didn't get it the first time, go back and retry it yourself until it makes sense. And this is really one of the more complicated ones that you'll see. There's others where you'll just have to do one modification at a time. But if you can do something like this, then that means that you're doing a good job of putting all the different modifications together and getting all the rules straight in your head. So make sure that you read all the instructions carefully, do the practice problems that are provided, step by step by step, and that way you'll become more efficient and effective at doing these types of problems without always having to go back to look at the steps. But of course, that requires you to start off looking at them first and studying them well.